Okay, so last lecture I think we have started to solve the numericals on fluid dynamics. I think we have completed the numericals on coefficient of orifices, that is coefficient of discharge, coefficient of velocity, and coefficient of contraction. And afterwards, I think we have solved some numericals on venturometer. Am I correct? Am I right? Or anything? We have us taken the numerical on Bernoulli's theorem? Anybody can reply. Am I right or anything? Bernoulli's theorem also we have completed. Somebody can reply. Bernoulli theorem, have we completed numericals on Bernoulli theorem? I think not.
No, sir.
Okay, thank you. Like this, somebody can reply. Okay. Now, first numerical we'll take on Bernoulli's theorem. Write down now. Numericals on Bernoulli's theorem. Numericals on Bernoulli's theorem. Whatever the Bernoulli's theorem we have studied, on that we have to solve some numericals. Okay. First numerical we'll take as it is. Whether this numerical number 6.1 is visible to you all? Write down numerical. Water is flowing through a pipe. Water is flowing through a pipe of 5 centimeter diameter. Water is flowing through a pipe of 5 centimeter diameter under a pressure of 29.43 Newton per centimeter square, in bracket gauge. Newton per centimeter square, in bracket gauge, and with minimum velocity of 2 meter per second. Find the total head or total energy. Find the total head or total energy per unit weight of the water at cross section which is 5 meter above the datum line. 5 meter above the datum line. So it is better to have the pictorial view of such numericals. Okay, so I will give the pictorial view here. So let us consider one pipe, and in that pipe here water is flowing. So let us consider this kind of pipe. So let inclined pipe is there. It will incline. Okay, so this pipe is having diameter 5 centimeters. So diameter of this pipe we can consider is a maybe capital D or small d. Okay. So let us consider small d is the diameter and is equal to 5 centimeter. So if you convert into meter, it will become 0.05 meter. Okay. Then this pipe is under a pressure. So this pressure inside the pipe, whatever the pressure is, let us consider one section. Let us consider one datum line. Okay. And this datum, let us consider this section and this point from the datum, the reference level datum means reference. It is 5 meter. Let us consider this point as a 1 point, point number 1, okay, 5 meter. So Z1 is equal to, we can consider 5. And pressure at point 5 is what? P1 or P is equal to, or Z is equal to, we can consider Z instead of only one head is there for Z only. Okay. And pressure P is equal to, how much pressure P? P is equal to 29.43 Newton per centimeter square. So I will write directly in Newton per meter square because SI unit we are going to prefer. So into 10 raised to 4 Newton per meter square. Okay. Then P we got, and velocity is V is equal to here 2 meter per second. This is given. So and what they asked? Find total head. So total head they asked. So I am writing here total head. What is total head in Bernoulli theorem? Anybody? Already is numerically solved, but here I will solve by our methodology. Total head is equal to, anybody? In Bernoulli theorem, what is the addition of total head means what? Which head? How many heads are there in the Bernoulli theorem? Total head means how many are there? Total head. One is, somebody can reply. Pressure head. Okay. Plus another is what? Kinetic head or velocity head. V square upon 2g. If you want to substitute one, so give every term as a 1 plus potential head is equal to Z1. Okay. Then Z1. So what is total head now? It will become P1 upon rho g. That we have to, what is flowing in this? Water is flowing. So therefore 29.43 is pressure intensity. Okay. साडे साडेतीन हां 29.43 29.43 into 10 raised to 4 divided by, so shall we already, I'll write here. So total head will write here. Total head calculation only here I will write. Equal P upon rho is 29.43. Into 10 raised to 4 divided by rho means 1000 water is there because fluid is water into 9.81. This is the pressure head plus kinetic head is what is kinetic head? V square. It is V. Velocity V is 2 square. Square divided by 2 into 9.81 plus Z means how much Z is there? Z is 5 meter. Is 5. And then you calculate in meter. So total head will come is a meter of water. Because it is a meter of water. How much is giving? He is giving 35.20 is coming. Your answer? Maybe it should come. 5.20. You already got? Everybody got answers? Understood? Very simple numerical, but this is very simple. Some little bit other difficult numericals are also there. Anybody have doubts? Understood? Please write message yes over like that. But we will proceed. Understood? Yes. So 30 point, yes, correct. Yes over. Nikita Pawar and correct. So yes over. Good. So this is the example on Bernoulli's theorem. Okay, so next numerical. A pipe through which water is flowing. The pipe through which water is flowing is having diameters 20 centimeter and 10 centimeter. Having diameters 20 centimeter and 10 centimeter. At the cross sections 1 and 2 respectively. At the cross sections 1 and 2 respectively. The velocity of water at section 1 is given 4 meter per second. Velocity of water at section 1 is 4 meter per second. So stop. Find the velocity head. Find the velocity head at sections 1 and 2. Find the velocity head at sections 1 and 2 and also rate of discharge. And also rate of discharge. Again, I will repeat. The pipe through which water is flowing is having diameter 20 centimeter and 10 centimeter at the cross sections 1 and 2 respectively. The velocity of water at section 1 is 4 meter per second. Find velocity head at sections 1 and 2 and also rate of discharge. So very simple. So again, what is given now? The pipe is there. What is given pipe is there. It is here. Taper pipe is there. So like this pipe, let us consider inclined pipe will take. So at one cross section 1, the pipe is 20 and at out section 2, pipe is 10 centimeter diameter. So let us picturely if you do then it will be easy to understand. So this kind of pipe we consider. This kind of pipe is there. Let us consider this kind of pipe. Taper pipe. This kind of taper pipe is there. Okay. And for this pipe, one they have considered like let us consider this section 1 1. So this is section 1 1 and another is what? Section 2 2. Okay. So at section 1 1 what they are given? So diameter D1 is equal to, it may be capital D1 or is equal to, I will write 0.2 meter. 20 centimeter means 0.2 meter. D2 at section 2 will consider this as a D2 is equal to 0.1 meter. Okay. So V1 they have given one that here the velocity of water at section 1 is 4 meter. So at section 1, so V1 what is given now? We will consider this as a V1 is equal to 4 meter per second. V2 we have to determine. What is V2? That we are not knowing. Okay. And they asked what they asked? Very simple. They asked find velocity head at section 1 and 2 and rate of discharge. So only simply they asked what? What is velocity head at section 1. Section 1 is equal to V1 square upon 2G. Okay. Secondly, what we can, they have given velocity head at 2 is equal to what? V2 square divided by 2G. Okay. So what? And then discharge Q they are. Three simple parameter they are. Okay. So velocity head at section 1. V1 we know. So therefore no problem to calculate it. So first answer what we'll do, V1 square upon 2G is equal to, easily, very easily we'll get. So already V we are knowing how much V is there, 4 square divided by 2 into 9.81. So how much meter of water you calculate? Somebody have to tell. Second, we have to calculate V2 square upon 2G. And for that, what we should know? V2 we should calculate. And somebody have to tell how we can calculate V2. How we can calculate V2? Which equation? Anybody? Now fluid kinematics we have learned. We are at the end of fluid dynamics. We should know it now. How we can calculate V2? Anybody? Continuity equation, anybody knowing? How we can calculate V2? V2 calculation, somebody have to tell.
A1 V1 is equal to A2.
Correct. A1 V1 is equal to A2 V2. So continuity equation is there. So to determine V2, what do I do? A1 V1 Q is equal to A1 V1 is equal to A2 V2. Very simple, correct. Gaurav, correct. A1 V1 is equal to A2 V2. Then this implies that V2 is equal to what? Here A1 upon A2 A1 upon A2 into V1. Okay. Now A1 we know, or A1 is equal to what? V2 is equal to what in that case? V2 is equal to K1 value. What is A1? Pi by 4 D1 square. Divided by pi by 4 D2 square into V1 is equal to pi by 4 will get cancelled. What is D1? 0.2 square divided by 0.1 square into what is V1 is 4. How much it is coming now? V2. Somebody can tell. V2 is coming as, somebody can tell V1 square upon 2G. That also I not calculate value. So V2 will be, first is 0.815 meter, 16. V2 is coming as 16. Correct. And V1 square upon 2G is coming as 0.815. So it is coming as what? 0.815 and V2 is coming as 16. And therefore V2 square upon 2G is coming as, anybody? I will write here. Is equal to V2 square upon 2G is equal to 16 square divided by 2 into 22 is equal to, anybody? is coming as 83.04 or 83.
Sir, 13.04.
V2 square upon 2G.
Yes, sir.
Okay. 13.07. Okay. 30 point na?
13.04.
13.
Yes, sir. 13.
13.004.
4.
Let it be. So for first answer is what? V1 square upon 2G is coming as 0.81 and V2 square upon 2G is coming as 13.04. Then they also asked rate of flow. Rate of flow means what? Anybody? How to calculate rate of flow? Rate of flow, I will calculate rate of flow. Rate of flow, how it is rate of flow? Q is equal to, anybody? There are two formulas. Rate of flow,
area into velocity.
area into any velocity, A means K is equal to A1 V1 or A2 V2. Both are same. Means A1 V1 or A2 V2. A1 is you can now calculate pi by 4 d1 square into pi by 4 d1 square into V1. That is V1 value I calculated. V1 is equal to 4. Then what is the value of is coming as anybody? It is equal to, here will go for answer. So Q is coming as what? A1 V1 or A2 V2. 125 means 0.1256 0.1256, yes, meter cube per second, or in liter per second it is 125.6 liter per second. 125.6 liter per second. Okay, now we'll little bit difficult numerical will take. From Asana booklet now we'll take one or two numerical. This numerical we have taken now. So what it had add on this numerical. Okay. So write down. Water is flowing through a pipe having diameter 300 mm and 200 mm at the bottom end and upper end respectively. The intensity of pressure at bottom end is 24.525 Newton per centimeter square and pressure at upper end is 9.81 Newton per centimeter square. Determine difference in datum head if rate of flow through the pipe is 40 liter per second. Write down numerical. I will give 2 to 3 minutes time for it. Write down. बोलो सोना जी चलो इधर न्यूमेरिकल ले तू आप पढ़ रही है दलकर सर उसकी तुम्हें दलकर सर ना ये कौन काल पढ़ रही ये क्या चला है इवेंट इस योगदान हाँ हाँ Okay. Return. Somebody can reply or okay. Water is flowing through a pipe having diameter 300 mm and 200 mm at the bottom end and upper end respectively. So to here the pipe is vertical because they have given upper end and bottom end, and at bottom end the pipe diameter is more. So this is this kind of pipe. This is front view. This kind of tapered pipe is here. Okay. So at this end we will consider as section 2 upper end we will consider as section 2 and this lower end we will consider as section 1 and water is flowing through a pipe having diameter 300 mm. So this is diameter is what D1 we can consider as capital D1 is equal to 300 mm is 0.3 meter. So I'll directly write meter, assign it. And D2 is, what is D2 value? D2 is, D2 is, am I audible? Okay. D2 is 0.2 meter. Okay. Then intensity of pressure at bottom end is P1. We can call it as P1. Pressure is there. It is P1 is equal to here for 24.5 to 5 Newton per centimeter square. If I want to convert it to Newton per meter square, here it should be into centimeter square, means it is 10 raised to 4. Okay. And 10 raised to minus 4. Okay. And it will become, when numerator it will become 10 raised to 4. Okay. And P1 upper end, P2 is 9.81 into 10 raised to again plus 4 Newton per meter square. Determine difference in the head, means what? If it is a Z2, if it is datum head Z2 and this is Z1, what is Z2 minus Z1? They are asking. Okay. And what is rate of flow is 43. And here both, and if you go for discharge is remaining same, Q is equal to 40 liter per second. So 40 liter per second. If I want to get in meter cube per second, what I should go for? Meter cube per second I want, then 40 divided by, anybody, 1000, and it will become, anybody, 0.04 meter cube per second. Okay, everybody understood up to this? Everybody understood this up to this? Yes, over message box. Nobody understood? Understood? Okay, yes or Nikita Power. Good. Everybody should reply yes or okay. Give reply like this so that I will get that your understanding. Okay, now we have to calculate Z2 minus Z1, and for that what we will do is, now area we can calculate, and we can calculate V1 and V2. So first of all we'll calculate V1 and V2. Calculate, we'll write here heading calculation of V1 and V2. Now we know Q. So Q is equal to, Gaurav told previously, what is Gaurav? Q is equal to A1 V1, and therefore V1 is equal to Q upon A1, and is equal to, what is Q value? 0.04 divided by pi by 4 d1 square. Pi by 4 d1 square. Okay, and you put value of d1 as a 0.3 and you calculate v1. Somebody have to tell me value. Well, I don't have numerical. I don't have the solved numerical meter per second. Okay, Similarly, V2 is equal to Q upon A to B A1 A to V2 Q upon A2 and is equal to again 0.04 divided by pi by 4 d2 square. Tell me the value. Fast. V1 and V2 value you have to write in chat box. Okay, somebody got 0.56. So it is value of V1 or V2. Somebody have write down value which is whether it is V1 or V2. Okay, 0.565 and 1.27. V1 is equal to 1. Okay, V1 is equal to 1.27. 0.5 is what? V1.
Yes, sir.
V1 0.5. Okay, 0.5. I will write 2 digits only, 0.56, and V2 is coming as 1.22.
27.
27. Okay. Both are in meter per second. Okay. Now we know V1, we know V2. Now we have to calculate Z2 minus Z1. P1 we know, P2 we know. Now which equation we have to apply? For both sections we have to apply Bernoulli's theorem. Now Bernoulli's theorem if you apply, here what will be equation now will become? Applying Bernoulli's theorem. What is Bernoulli's theorem? If losses are not given, then P1 upon rho G plus V1 square divided by 2G plus Z1 equal to P2 upon rho G, okay, plus V2 square upon 2G plus Z2. Therefore, Z2 minus Z1 they asked. Z2 minus Z1, so it will be P1 minus P2 upon rho G plus here V1 square minus V2 square divided by. Okay, and calculate now. P1 upon P1 you know, P2 we know, V1 we know, V2 we know, and G we know. So it is meter. Can you able to calculate? Please tell yes or no. I will give 3 minutes to you to calculate it. Calculate. Tell me the value in chat box. Tell me understood yes and over like that. And answer also right now. We'll cross check the answer. Okay, somebody will calculate it. So somebody Dikshad Mille, I think. Dikshad Mille solved. Nikita solved 14.92. What is this difference? Z1 42.92. 9. So I will consider 142. 14.92 will consider because majority is 92. 93. 14.93. Depending on digits calculation, it's some variation here. Okay. So Nikita Pawar, Richard Mille, and Shivani Nani got answer 14.92. Again, okay, we have 4 data over for Rakesh Birazar from the first, and Rakesh 14.96, and Kumar Alikar also 14.93. Rakesh, you are so 90, 14.90. 14.93. Is it over? Shall I proceed to next? One numerical, simple numerical will go, and we will go for chapter number 4. Shall we go? In write in message in chat box. Yes. So we will proceed to next numerical. Those are not solved. Yes. Oh, okay. which we have taken. Liter per second. But I think we have taken how much discharge? 40 only. 13.96 is the correct value. Correct. Somebody was correct. What?
मीटिंग झाली किंवा मग सोया
कुठं?
सोलापूर
मीटिंग करायचं
ते युवा महोत्सव मीटिंग
ऑनलाईन. युवा महोत्सव ऑनलाईन आहे. ऑनलाईन माझ्या
19 ऍक्टिव्हिटी आहेत.
तुम्ही कोणत्या तुमचा रोल?
मी आता डिस्ट्रिक्ट कोऑर्डिनेटर समन्वयक मी.
तुम्ही युआर कंडक्टिंग कुठल्या कॉलेज काय नाही
5 कॉलेजमध्ये 6 विद्यापीठ 19 आयटम ठरवले त्यांचे. आता त्या 2 इन्क्वायरी कमिटी बसणार त्याच्यावर. त्याची इन्क्वायरी करायची सगळे आणि काय काय होतंय ते चेंजेस रेकमेंड करायचे ऑनलाईन साठी. त्यासाठी बसलोय. काय चाललंय? चालूच आहे की मावा. आवाज दोन बोल. विद्यार्थ्यांच्या दृष्टीने जरा
Okay, so last numerical we will take on this Bernoulli theorem. So we take this 6.6 numerical number 6.6. The water is flowing. Okay, the water is flowing through a taper pipe of length 100 meter. Of length 100 meter. This is 100 meter. Having diameter 600 mm. Diameter 600 mm at the upper end. At the upper end. And 300 mm at the lower end. And 300 mm at the lower end. At the rate of 50 liters per second. At the rate of 50 liters per second. The pipe has a slope of 1 in 30. Pipe has a slope of 1 in 30. Find the pressure at the lower end. Find the pressure at the lower end. If the pressure at higher level is 19.62 Newton per centimeter square. 19.62 liter per centimeter square. We take down the numerical. 1 minute I will give it to you. Okay. Now tell me the values. This kind of pipe is there. To taper pipe. Already I have seen the sketch. This is a taper pipe. Diameter D1 is given. So you will consider this as a diameter. What they have given? Which diameter first they have given? Diameter of taper pipe. Length 100 meter and having diameter 6 centimeter at upper end. So upper end will consider as a D1. So D1 is equal to 0.6 meter. D2 is equal to, anybody will tell or I have to go back? D2 is equal to 0.3 meter. And the pipe length of the pipe is what? This is pipe length is equal to this pipe length L. L is equal to 100 meter. Anybody? Prathamesh? Roll number 50. Prathamesh, you want to tell something?
No, sir.
Okay, so length is 100 meter. And a slope means here y by dy by dx. So length, if you consider one triangle, this length divided by this ratio. Let us consider this as a z1 and this z2. Okay. Roll number 16. Komal, please unmute. Hello, Komal. L is 100 meter, and this dz we can consider z1 minus z2. This we have to calculate, and for this dy by dx is equal to slope is equal to 1:30. Okay, so dy by dx or tan theta we can consider. So is equal to tan theta. Slope is always equal to given by tan theta is equal to 1/30. So here also we can go for if it is a or we can calculate theta. Okay. So this, okay. So tan theta is equal to 1/30. If you know to sin theta is equal to from this we have to calculate theta is equal to. So we can calculate theta is equal to. Anybody? Theta is equal to. We can get theta is equal to. And then afterwards we want to z1 minus z2. For that I have to go for sin theta. or if you are having option to calculate Z1 minus Z2, sin theta is equal to Z1, the Z, or we can call Z1 minus Z2 divided by L. Okay, so theta, somebody have to calculate. Tan theta is equal to 1 by x, 1 by 30. Somebody can calculate theta. Huh? Lecture झालं. असं एक कठीण. डोंगरी
No es. No. ¿Qué pregunta?
नंतर मारतो ते 3 Okay, so sin theta is equal to Z1 minus Z2. So theta, somebody have calculate theta. Value of theta. And 1 by 30 means 0.33, or theta is equal to, anybody of you? Z1, this will be Z1. That time itself will consider as a at this center level, and this is Z2. So 1 point, what is this? 1.90. Shubham Gandole, 1.90 is theta, or what? Or Z1 minus Z2. Somebody tell value. What value is?
Theta.
This will be Z2. Theta is 1.9. Okay. Then sin theta. Now sin of 1.9 is equal to Z1 minus Z2. We can calculate now. Z1 minus Z2 divided by L. L means 100. And now tell me the value of Z1 minus Z2. What is value? Anybody? Anybody? So Z1 minus Z2. So sin of 1.99, if it is coming 9, 1.9. Z1 minus Z2 is coming as anybody?
3.31.
3.33.
33.31.
33.31. Okay, 33.31 meter. Everybody got how to calculate this? Z1 minus Z2. Difference in elevation. It is nothing but what? Difference in this two section elevation. Okay. 33.31. Everybody got this? Understood? Now what they have given again? And they asked her to calculate pressure at higher level. They asked her. Higher level means
हॅलो
हा
सर थिटाची व्हॅल्यू रॅडियन मध्ये काढायची का डायरेक्ट काढायची
डायरेक्ट चिटामध्ये डिग्री मध्ये
डिग्री मध्ये का
हा
ओके
हा
हॅलो सर.
हा हा बालाजी
Z1 minus Z2
हा
3.31 येते. 33 येत नाही.
3.31.
31.
Okay. So majority of you tell me answer because I mean we are having answer, but they have taken another methodology to solve the problem. Okay, 3.33. Okay, let us will consider. Correct. It is 3.33. So somebody have to do the calculation. 3.31. Okay. So I think Shivani and Nani also getting okay. Majority are getting 3.30. You do the calculation correctly. Where I am going with simple way to they have taken some 3.31 meter. Z1 minus Z2. Correct. So this will be Z2. Sorry. Z1 minus Z2. It's coming as 3.31 meter. Now they have given what? Discharge they have given. So Q is equal to, they have given as a 50 liter per second. And it is equal to what? 50 liter means what? 0. It should be divided by 1000. So 0.005. No, 50 divided by 0.05. Not sorry. Point 0.05 meter cube per second. Okay. Now this is Q. Now from this Q value we can calculate V1 and V2. What is V1 always? V1 is equal to Q divided by A1 and is equal to what? Q is equal to A1 V1 from that. Therefore Q is equal to Q divided by pi by 4 D1 square. Okay. Everything you are knowing. So you are knowing Q 0.05, D1 is equal to 0.6 and you calculate V1 in terms of meter per second. Similarly, V2 is equal to Q upon A1. Q is equal to A1 V1. Like this, Q is equal to A2 V2 also. So Q is equal to V2 is equal to Q upon A2 and is equal to again Q is 0.05 divided by pi by 4 D2 square. And this is coming as meter per second. You tell me the values. Point 177. 0.70. V1 is coming as anybody? Zero point 177 and who has calculated first? Diksha Admi 0.177 and 0.70. Okay, very good. Zero point 70. Roughly I am taking here. Okay. Now we got V1, we got V2, we know Z1 minus Z2, and they asked to calculate what? Pressure at higher level means what? P1 they have given and they asked P2. So here now V1 we got, V2 we got, Z1 minus Z2 also we got. So applying Bernoulli theorem at section 1 and 2, so what will go now? P1 upon rho G plus V1 square upon 2G plus Z1 is equal to P2 upon rho G plus V2 square upon 2G plus Z2. Okay, now P1 they were given, I think. Correct, na? P1 is given. Who will tell P1 value? P1 is coming as here 19.62 into 10 raised to 4 Newton per meter square. So I will directly convert it, assign it. 19.62 into 10 raised to 4 divided by 1000 into 9.82 plus P1. What is P1 value? 0.177 0.177 divided by 2G. Point 177 square into 2 into 9.81. Now what we'll do? Z1 minus Z2 will brought together this Z1 Z2 and or directly P2 we want in Z1 minus Z2 we'll write here. Z1 minus Z2 plus minus V2 square upon 2G is equal to P2 upon rho G. This P2 upon rho G we have to calculate. Or what they asked us to calculate? What is the pressure? Pressure in intensity means pressure in P2 we have to calculate. First of all, we will get P2 upon rho G. You do the calculation, you will come as a meter of water. Meter of water. Anybody will go get this answer? So 22.5085. Okay, but okay, let it be now. We'll solve 22. Somebody got P2 is coming as 22.8584 Newton per centimeter square. Okay. First of all, but we will calculate first P2 upon rho G, and then I will tell how to calculate this 22.84 Newton per centimeter square. 85 derivative. First of all, we'll get P2 upon rho G, and P2 then P2 is equal to what we are interested in to calculate P2 1000 and G. So it is 22.84. Somebody is getting, so it's the correct answer. So P2 upon rho G, what is the answer of P2 upon rho G? Is coming as 23.3 meter. 23.3 22.3 meter of water. So we'll stop the numericals now on Bernoulli theorem. Shall we? Shall we stop? Shall we stop? And I declare that the unit number 3 is completed. All numericals, Bernoulli theorem, Venturi-meter numericals, and they asked the numericals on coefficient of discharge, CD, CV, and CC. Other numericals are there in the book, etc. You can solve independently. Other numericals are there in the assignment, Z1, Z2. So that numerical, I will modify assignment and I will send on today WhatsApp group as well as these notes. Is it okay? Is it okay for you? Or shall we take more numericals? Yes, Shubham. Okay, Rakesh brother. Yes, yes, yes. Good. So we'll stop unit number 3 now. And we'll go to unit number 4 now today. As far as our syllabus is concerned, so up till now I think we have completed the Euler's equation along a streamline. But applications already you covered. No numerical treatment on orifice and pedagogy. So all these numerical treatment were covered. Then Venturi-meter we have covered. Bernoulli theorem numericals we have covered, and flow through sharp small orifice means both numericals we have covered. Okay, this completes our unit number 3. Now we'll go to unit number 4. This is also very, very important unit of fluid mechanics. Write down unit number 4 is a flow through pipes. Everybody is getting this unit number. Write down syllabus. Today will at least cover the losses, flow through pipes. Flow through pipes is the unit number 4. Write down syllabus. So flow through pipes means what? Now whatever the pipelines we are seeing when we want to transfer the fluid from one place to another place, we need the pipelines. Then when we are transferring the fluid from one place to another place, definitely there is a loss of head or loss of energy for the fluid. So total head, we know that it is addition of pressure energy, kinetic energy and potential energy. But when we want to transfer the fluid from one place to another place, there is always certain losses occurs in the pipeline. So these losses, first of all, we have to understand which are the different losses of the. So up till now, in unit number 3, we have not considered the Bernoulli theorem here with losses. We have considered Bernoulli theorem in ideal condition, but in the real case here, there are losses existing for the fluids. So we are going to study the different losses. So these losses are categorized into 2 categories. One is major losses and another is minor losses. Then one equation is there, Darcy-Weisbach equation. This is related to major loss. Then afterwards we are having different losses, that is loss of head in pipe connections and fittings. So minor losses in equivalent pipe and hydraulic gradient line and total energy line, one concept is there. And siphon, okay, and then flow through pipes in series and parallel, and then efficiency of power transmission. So these are going to be the syllabus of us. So first of all, we'll see the different energy losses occurs in the pipeline. So write down first energy losses. Energy losses. We'll go for tree diagram. Okay. Energy losses in a pipe flow system or in a fluid flow system. When a fluid is going to be flowing from one place to another place, and definitely there are the energy losses occurs in the pipeline system, fluid flow system. Okay, so first of all we'll go for the energy losses, or it is also called as head losses. So write down with me. So these are the energy losses. Or it is also called as head losses. Okay. These energy losses are classified into 2 categories. So first write down, energy losses are classified into 2 categories. One is anybody major losses. And another category is there, it is minor losses. Next class I will start revision with this. So there are two kinds of energy losses are there. One is energy major loss, another is minor losses. So these major losses are only due to friction. Due to only friction. Here what is category? You write down also these are very due to friction only. Whatever the friction is there in between the pipe, internal surface of pipe and the flowing fluid. So that losses are called as major losses, and these major losses are due to friction only. I am writing word again only. What is that? Major losses are there. These are only due to friction only. And to calculate these losses, we have two equations we are using in fluid mechanics. One is Darcy-Weisbach equation. Darcy-Weisbach equation. And second one is here Chase's equation. So these are the names of scientists. One scientist is there, it is called as Chase. So Chase's equation. So Darcy's equation we are going to derive in our class. Chase's equation we are going to take only the formula. So first category of energy losses is what? Major losses. Energy losses or head losses are classified into two categories. One is major losses. It is due to friction only. Second one is Darcy-Weisbach equation. And this can be calculated by the two ways, two methods. One is Darcy-Weisbach equation we can use. Another is Chase's equation. Then minor losses. So when fluids are going to be flowing, the major losses means friction, okay, in between pipe and that flowing fluid. And another losses are minor, but minor losses we can consider or not consider. It is up to us. If you want accuracy, we have to consider major losses always because it is major quantity. Minor losses as per our wish. If you want to consider accuracy, then we have to consider minor losses also. So what are the minor losses? So many losses here it is coming under the category of what? First minor loss. We will see a formula afterwards, but now at least how to calculate. So first minor loss is there. Loss of head at the entrance of pipe. So when the fluid is flowing, so loss of energy, loss of head at entrance. So when the fluid is entering into the pipe, and some losses are energy losses are going to be taking place. Means let's suppose this is reservoir is there, and from this reservoir tank is there, and tank we are taking the water. When it is entering into the reservoir, okay, loss of it here at the entry in pipe or pipe off pipe. Loss of it at entry of pipe. Okay. Then second will go for as it is entering also loss is there. Second is what? Loss of head loss of head at, because this chapter is very useful for here MCQ types questions at exit of pipe or exit, not pipe or anything. At entrance, loss of it at an entry of pipe, loss of it at exit. Okay. Then third loss. Now what happens? There are pipe fittings we are going to use it for the pipeline. So suppose this is one pipe is there, and we want to connect another pipeline to us in rectangle, right angle to here, right angle direction. Then we are going to use this bend. Pipe fittings are there. It is called as pipe fitting. Okay. So these pipe fittings, different pipe fittings we can use. One is here This is pipe bend is there, okay, and T is there, like this T is there. So one T is there, pipe bend T, then elbows are there, okay. So here, due to use of these pipe fittings, some losses are occurs in the pipeline. So loss of head, due to bend. Loss of head due to bend. Then another is there, pipe fittings are there. Loss of head or energy, energy loss of head due to, this is one pipe bend is there, or loss of head due to pipe fittings. Pipe fittings. Okay, loss of head due to pipe bend, loss of head due to pipe fittings, and fifth one is what? Fifth one, loss of head due to pipe fittings, loss of head due to pipe bend. Then sometimes what happens? The pipes is of not uniform diameter. Come on. नोटीस पाय काढायचं ऑक्टोबर मध्ये काय नोटीस काढली ऑक्टोबर काय मेल बाकी पुढचं कुठ नाही काढायची द्यावं लागतं असं ती पण द्यावं लागली एक कॅल्क्युलेशनसाठी HOD साठी ते loss of head due to pipe fittings, okay. Then loss of head due to, then pipe is not of uniform diameter. Sometimes pipe is what, it is like this, small pipe is there, and another again it is what, pipe is get enlarged, okay. So this is what, due to this, again as the velocity of the pipe is changing suddenly, okay, the energy loss happens. So this is called a lot when our velocity, because in pipe, smaller pipe, velocity is more, V is more, and always remember that in larger pipe velocity is V is less. So when velocity is changing drastically from more to less or less to more, then energy losses will occur, and that is called what, loss of head, loss of head, loss of head due to sudden enlargement of pipe, enlargement of pipe. Sudden enlargement of pipe. Then again one example is there, that sudden enlargement, then sudden contraction also there. If this is another pipe here, if this pipe is less velocity, again one this pipe, again third pipe we are connecting. Here pipe is enlarged, pipe is suddenly contracted. So another loss is there, that here loss of head here loss of head due to sudden contraction, or I will write here contraction. You write your notebook sudden contraction. Sudden contraction of pipe. Okay, so loss of head due to entry of pipe, loss of head at the head at exit of pipe, loss of head due to the pipe bend, loss of head due to pipe fittings, loss of head due to sudden enlargement, loss of head due to sudden contraction, and seventh one in this category. And there are different formulas. That formula we have to remember the formula. Loss of head due to sudden obstruction. मीन्स सपोज इन अ पाईप मधून फ्लो चालू आहे आणि एकदम काय तर दगड वगैरे अडवा आला तर इट इज कॉल्ड एज लॉस ऑफ हेड ड्यू टू सडन ऑब्स्ट्रॅक्शन. These are different energy losses categorized under minor energy losses. Loss of head due to sudden obstruction. So these are the different energy losses occurs in the pipeline. So again I will repeat, energy losses are classified into two categories. One is major losses and another is minor losses. Always we have to consider major losses. Minor losses, if you want accuracy, we have to consider minor losses. Means major plus minor. Always compulsorily we have to take major losses. Of minor losses, it's optional for us. Major losses are due to friction only. So these losses are only due to friction. So Darcy-Weisbach equation and Chedge's equation, with the help of them we can calculate. Another thing is there that minor losses, there are the different formulae to calculate minor losses. So or different types of minor losses are example, loss of head due to entrance. If the reservoir is there and the pipe is there, so when the pipe water is flowing into the because it is more area and pipe area is less, so velocity change will occur. And loss of head at entry of pipe, loss of head at exit of pipe, loss of head due to pipe bend, loss of head due to pipe fittings like T, elbow, reducer. These are the different pipe fittings we are using for the pipeline connection. Loss of head due to sudden enlargement, then loss of head due to sudden contraction, and loss of head due to sudden obstruction. These are the energy losses. Have you written? Have you understood clearly? Tell me, so that will, if somebody is not understood, I will repeat. Very simple, like a theory. Now, other next class we are going to take the formulas for all, and these formulas we have to remember so that we can solve the numerical. Write down in chat box. Understood? Not understood? Please write down. Yes, yes, okay. Then, as everybody understood, no doubts are there. We'll stop here, but before that, I have to take present. Today, why some students are less? Somebody can reply. Many less students are joined, or every afternoon. This is the situation. I don't know why you are not attending. Sincere miss, or your friend, you are attending. Crystal clear. Okay, very good. Rakesh brother. Okay, thank you. Okay, roll number 1.
Present, sir.
2,
Yes, sir.
3,
Present, sir.
4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16,
Present, sir. 15 present.
17, and then okay, 15 present, 16, 17,
17 present, sir.
okay, 18, 19,
Yes, sir. 19 present.
okay, Ajit, 20, 21, 22, 23, 24, 25, 26, 27,
Present, sir.
okay, 27, 28, 29,
Present,
30,
sir. 29 present.
29 present, okay, 30,
Yes, sir.
31, 32,
Yes, sir. 32.
33,
Yes, sir.
33 present, 34, 35, 36, 37,
Present, sir.
38,
37.
Present, sir.
37, 38,
37.
37, 38 present, 39,
Present, sir.
40, 40, 41,
Present, sir.
42,
42 present, sir.
43,
Yes.
44,
44, yes, sir.
45,
Yes, sir. 45.
46, 46, 46, 47, 48, 49,
Yes, sir.
50,
Yes, sir.
50, 51,
Yes, sir.
51, 50 present, 51, 52, 53, 54, 55, 56,
Yes, sir. 55.
56, 57, 58, 59,
57 present, sir. 57.
57 present, okay, yeah. Then
Sir, 58 present.
58, okay, 59,
Present, sir.
60,
61.
okay, 61 present, 62, 63, 64, 65, 66, 67, 68, 69, 70 present, 70, 70. Okay. So we can stop here. Next class will take
Yes, sir.
accordingly.
30 also present, sir.
30, 32, 30 present, 32 present. Okay, yeah. Anybody?
Sir, 17.
70 also present. ठीक है.
Sir, 49.
49 present. हाँ.
Sir, 70 present.
70 present. Okay, I have taken. Okay, leave and join another class. 43 present. हाँ. ठीक है, you can leave the class now.